Hello students, this discussion is going to be very short. We're talking about linear function applications, and we're going to do something just a little bit different this time. We're going to look at what some of the problems are going to look like here. As we kind of scroll through here, we can see, all right, there's number one, a construction crew is lengthening a road, blah, 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 blah. Let L represent the total length of miles, then use this equation to find blah, blah, blah. Okay, so it's looking like word problems, okay? And if we look through here, this is going to say something like, write an equation relating C to S, then use this equation to find the total cost. Or write an equation relating W to T, then use this equation to find the total amount. Okay, so definitely we've got some word problems expecting us to write equations, write an equation and then graph it. Okay, so if we can write an equation, we can plug in a number. If we write an equation, we can graph it. A lot of this looking at a graph, then sort of analyzing that and things like that. The thing is that a lot of these skills are things that you've had in your previous math classes. So for me to go back and sort of go through a lot of these would probably just be a lot of excessive review. I'm going to go over just very briefly one or two small things. But the thing is that once I show you how to solve one of these problems, then pretty much you can solve every single one of these, and the only thing that's going to change is the difference in the numbers. And in this sort of situation, I am not concerned with you being able to know a process and then repeat that process over and over again. What I'm really concerned about here is, can you look at a word situation, a verbal situation here, maybe a graph, maybe some numbers with it, or whatever, and perform the analysis on that. And so for me to go through and work a series of problems, even if I do 5 or just 6, well, then that's 5 or 6 problems that when you actually work on the homework, you're never even going to have to think on those. You're just going to say, oh, this number goes here, this number goes there, and I'm done. Let's go to the next one. And that's not really what I want to happen. I want you to think about the relationship here of what happened. The construction crew is lengthening the road, and this is the total length. This X is going to be the days. And we've got this equation. What does this, what's the answer to this question? How does that relate to a positive or negative increase and change and things like that? Of course, I'll be available to answer questions throughout class, but there's some of you who will pick this up. In all reality, probably all of you pick it up very quickly, knock it out no problem, and for me just to actually start doing some problems here would be a little bit of a waste of everybody's time. Alright, so let's just go over a couple of the formulas and then you can get started. Hello students, so in this short video we're going to be talking about linear function applications. This is probably a lot of stuff that you already saw, maybe remember from Algebra 1 or maybe even Algebra 2. So basically, anytime you have a linear function, obviously the graph is going to look like a line, and the equation is going to have the form y equals mx plus b. However, sometimes it's more advantageous to have it in the form y equals b plus mx, because that b could stand for the initial value. Now you said, initial value of what? Well, in any functional relationship, you're going to have the dependent variable and the independent variable. And in this equation here, y depends on x, so y is the dependent variable. That being said, when x is 0, maybe that's time is 0, or the distance that you've traveled is 0, and maybe cost depends on distance or something like that. Whenever that's 0, this whole term over here will be 0, and so your dependent value will be this right here. So this is your start value or your initial value or whatever. Once again, the dependent, that would be the dependent starting value. X, obviously, as I mentioned a second ago, that's the independent variable. That's whatever can change freely in that relationship between the x and the y. And then m, I'm sure you know that's the slope, but in these sort of problems it's more helpful to think about that as the rate of change. Specifically, it's the rate of change in the y over the change in y over the change in x. Some expressions that you might see, for instance, like $5 per month. that would correspond to that ratio right there, 5/1, or $5 over 1 month. It'll be a slope of 5. Maybe you've got a word problem that talks about 3 feet per pound, so that would be 3 feet over 1 pound. So you can see this per business. The word per normally is going to refer to the fraction here. Or you might see something like 72 cents each minute. So that would be 72 cents over 1 minute. So sometimes you'll have the word each there to represent that fraction, which corresponds to the slope and the rate of change. All right, that's pretty much everything that you're going to need to be successful here. I'll let you get to working on those math problems.